All right, well, we've considered sine functions, cosine functions, and tangent functions. And now we're going to take a brief look at other trig functions. Now, when we're talking about other trig functions, of course, we're talking about the cosecant, the secant, and the cotangent. Now, these are reciprocal functions in that the cosecant is equal to 1 over the sine, and the secant is equal to 1 over the cosine, and the cotangent is 1 over the tangent. And when we graph those, we're going to have to use that format because our graph doesn't have little buttons for cosecant, secant, and cotangent. Well, let's see what kind of problem we're asked to do here. All right, we're asked first to find the period of y equals the cosecant of 2 theta, and then we're going to graph it. Okay, so let's think about the period. Now, the period of the sine function was 360 degrees. So the period for a cosecant function is 360 degrees divided by the absolute value of b. And of course, in this case, b is equal to 2. Remember our basic format in this. Let's see, where could I put this? Well, right here. Y equals a times the cosecant of b theta. Okay, so what have we got here? Well, if the period then is 360 divided by the absolute value of 2, which of course is 2, then our period is 180. Now we'll have asymptotes in here because this 1 over the sine, 1 over the cosine, 1 over the tangent, we can't divide by 0. So anytime we'd be confronted with having to divide by 0, where the sine equals 0, well, we're going to have an asymptote, and we can determine where they are by 360 in the case of a cosecant function, and a secant as well, as far as that goes, but not a cotangent. Cotangent would be 180 over the 2 times the square root of 2 times the absolute value of b. So this is 360 over 2 times the absolute value of 2, which of course is 4. Which is 2. The absolute value of 2 is 2. So we got 360 over 4, which then of course equals 90. So we'll have asymptotes every 90 degrees. And you see again, we're in degree, not radian mode. And let's see, what about amplitude? Well, it's undefined. Well, let's proceed then and graph y equals the cosecant of 2 theta. And I guess before we do, what's it kind of going to look like? Let's just say we're right here. It's going to kind of look like this, and this, and this. Let's go see if that's true. All right, well, here we are. We're going to graph the cosecant of 2 theta. First thing I want to do is I want to check my mode. I'm dealing with degrees. I verify I'm in degree mode, so that seems to be good. And I'm going to take a peek at my window settings. Let's see. We've got a period that's 180. We're going to have asymptotes at every 90 degrees. So x min, x max, and x scale I'm satisfied with. But I'm going to need to change the y minimum and the y1 so I can see the graph, because it's either going to be above 1 or below -1. So I think I'll just go with -2, 2. All right. Okay, so let's graph these. Clear out everything first. Okay, so we're going to be 1 over the sine. So let's go 1 divided by, and I like to put these in parentheses, the sine of 2 x, close parentheses, close parentheses. Well, I did that in y2, but that'll be okay. Let's see what our graph looks like. It should show up in red. All right, well, there it is. Everything up here above the x-axis, the graph appears above 1. And then down here in the negative part of the y-axis, everything appears below -1. And our scale was 45 degrees, so we've got an asymptote right here on the second tick mark, so that represents 90. If we go from one period to the next, let's go from here to here. That's the bottom of this is at 45. The bottom of this is at 90, 130, 185, 180 plus 45, 225. 225 minus 45 is 180. Okay, so there's our period, 180. Same thing down here. And so there we go. Now, just for fun, let's just graph just plain old cosecant of x. So we'd have 1 divided by the sine of x. That's going to appear in blue. And you can see here that what happens is that everything's shifted. We now have 360 degrees for the period, and we have asymptotes at 180. And just for a little further fun, let's just graph the sine of x and see how it compares to 1 over the cosine, or cosecant of actually 2x. But well, let's just do 2x so we can get a comparison. You get a visualization of what's going on. All right, there's the sine function. There's the cosecant function. And if you notice, it just flips over portions of that. Like from here up through here, it just flips it upside down. Okay? Anyway, those last 2 or 3 things I just did for fun, just for a little bit of different variation. So if I want to graph the cosecant, the secant, it's going to be 1 over the cosine. If I want to graph the cotangent, it's 1 over the tangent. And those are illustrations of graphing the reciprocal functions.